Sometimes, you know, when the mood hits them.
Yeah.
Yes, I'm recording. So you can record this later and say, Mr. Resney is a jerk.
Can it hear me?
Yes, it can totally. You'd be amazed how well it picks up students. The mic's like it's underneath here, pointed the wrong way. It picks up students beautifully. My voice is all gravelly and weird, but your voices are like perfect. Like I should, or I should point the thing another way. Point it at you guys. Let you guys suffer the face. Okay, so for homework, hopefully, or just in general, or we did it right before you left, I don't remember which, you should have done this long division. Since Solon didn't have her homework out, she gets to do this problem for me. Did a long division for us, which of course is what she hates, because she would have used synthetic division on everything. You do have to know how to do long division on a couple problems, right? Anything that is formatted like this, and we'll talk about that in a little bit, so make sure you know how to do it. So we do some long division. We did it here, so never. Oh, it's on your paper. Look how beautiful that is. All right, so I gave you three for no good reason. Let's do a little long division. What do you got? What times x gives me x cubed? X squared. I love it. X squared gives me x to the third plus 3x squared minus minus. I get x squared. Agree with that. Bring down my negative 3x. What times x gives me x squared? X. So I get x squared. I heard a voice. You got good?
I'm sorry, yes.
Plus 3x. Change my signs before I forget, and I get negative 6x. Agreed. Minus 5. What times x gives me negative 6x? Negative 6. And I got negative 6x minus 18. Change my signs before I forget, and I get 13. Agreed on that. Plus 13 over x plus 3. Now, on a side note, does this actually work? Because, you know, normally I use long division to prove it works, and since you guys don't know how to do long division, that's really not a good proof, is it? So theoretically, if I take this and multiply it by this, I would get this, right? That's what division means, right? I take this, multiply this. I'm only going to do it one time. You guys ready? And that is synthetic division. Synthetic division comes from the idea of the remainder theorem, and that is, hey, if I multiply this by negative 3, I get the remainder, don't I? Right? And so if you were to take the 1 that was out in front of here, the 1, the 4, the negative 3, and the negative 5. If you were to take the 1 and multiply it by negative 3, not positive 3, because I want to use the remainder theorem to get the remainder, what are you looking at the door for? Who's out there? Is she cute? You cute? I'm sorry, I wasn't trying to pigeonhole you in any way. I apologize, man. I do. All right. Right, so we're going to plug in a negative 3, right, because that's what's going to make it a 0 to find the remainder, right? So we aren't plugging in the plus 3, we're plugging in negative 3. So I bring down the 1. 1 times negative 3 is negative 3, isn't it? So the remainder will be negative 3 when I get done. And then 4 minus 3 is 1, right?
Oh.
1. Look at the 1. And then 1 times negative 3 is negative 3. Agreed? Which is the remainder from the previous one. And then negative 3 minus 3 is negative 6. Oh, look, that's what we get when we add up that with the remainder. And then negative 6 times negative 3 is 18. 18 gives me 13. Even worse than that, this is the original, right? So this is 13 over x plus 3 plus negative 6x, negative 6.
No, whoa.
Negative 6. This is x, and this is x squared. So once somebody came up with it and said, why am I doing that? That's ridiculous. This is synthetic division where it's wonderful, isn't it? Now, a warning about synthetic division that's going to come up on your test because you're going to use this synthetic division a lot. You're going to forget about our friend long division. This only works if your format is x with no number in front of it, no squared, no nothing, plus or minus, one of those two choices, a number. That's the only time synthetic division works. Every other case, it does not work. Does that make sense? So you may only use it for this particular case. Now, the good news is this. What am I trying to find? Mr. Reggie, let's see how much you've been engaged so far, because you weren't here the first day, so let's see if you can get caught up here. What are we trying to do? What's this chapter about? I think it was Mr. Durr. I could be wrong. I had a problem up on the board like the first day. It was X, and you weren't here, right? It was like this problem right here. And I said, hey, we're going to try to find the zeros. He said, well, you can't because you don't have the quadratic equation. I said, but that's the point. We're going to find the zeros. To find the zeros, I need to factor this. What do the factors look like? Parentheses, x plus or minus a number. So we're ultimately going to use synthetic division. Why? Because we want things to look like this when we're done. We want to factor out x plus something or x minus something. That's how we get the problem done, right? If I were to do this, I'd end up with this, right? X plus something, maybe x minus something, right? I'd end up with something like that. Does that make sense? And so we're going to be checking these sorts of things. So the good news is what? Synthetic division is going to work beautifully for us because it's exactly what we want to do most times. Okay? Watch out for the test, though. I might put an x squared on there, and then suddenly you've got to remember, oh, not synthetic division today. Right, Solon? All right. So I did a really quick synthetic division here. Let's remind you of the steps. The steps are as follows. You bring down the first of all, you write down the numbers, just like you did over here, right? All the coefficients. You must remember this. If there's a gap, if there's not an x squared there, you have to put in a 0, right? Still follows. You have to do that, otherwise you're going to probably placeholder. And you won't see it here. It won't even confuse you. You're like, oh, I don't even know what, not missing anything. Second thing, you bring down the first one. Multiply it by, not the plus 3, the what makes it equal to 0. Right? Okay? Then you plunk it here. Then you just add. Repeat, add, repeat, add. And then you write out your answer. This term on the end is your remainder. It goes over the fraction. Then you go backwards through them. This without an x, this with an x, this with an x squared. The x will be x to the third, x to the fourth, x to the fifth. Got it? All right. We're loving it. Everybody try number 1 in the back. I only give you 4 problems to do with synthetic division. What a softie. I've got x, so I got 3x squared plus 4x minus 12 divided by x plus 5. So I'm going to put what in the corner? -5, and then I'm going to list these variables. It's going to be it's going to be 3, 4, -12. And actually, I wanted to put the 5 someplace different. I kind of messed that up. I'm a little rusty with synthetic division myself, apparently. I'm going to put the -5 right here. Reason we'll get to later. Okay? So what do? Bring down the first one. 3. 3 times -5 is -15. 4 minus 15 is -11. -11 times -5 is 55. 55 minus 12 is... We're going to have some 8th graders here that can answer this question. 43? Yeah. You're on still Nepal time. It's probably they probably do math differently there. All right, so my answer would be 43 over x plus 5. Put a little plus out in front. Minus 11 with no x on it yet. And then 3 with an x on it. And if there's another term, it would be x squared, x to the third, x to the fourth. And they list them up. And that's my answer. Life is good. Good for good? Crushing this. I'm boring you. Sorry. Door good? All right.